are common. And, you know, at our office at SPY, all of our stuff goes out through one IP. And apparently, I'm sorry, Bob, I got to do this because it's a funny story. Bob crawled Slashdot one day by mistake, and Slashdot banned our IP for a couple. It was how many days? It was 1 or 2? I guess not. He's hiding back there. But they banned it because we're all coming from a single IP. And so, but it's not common to have a single IP actually be 100 people, but we're behind a proxy and a NATed firewall. So, you know, this is all tough. Further, even if your IDS can see us, it's very easy to elude it. You know, screw the fact that you can no longer tell when you're under attack or not. Now you've got to look for specific signatures. But the thing is most IDSs are either packet-based or stream-based. They're either looking at the IP packets or they're looking at the TCP stream. Robert Graham gave an awesome presentation at TourCon where he went out, got the latest version of Snort, grabbed the latest exploit of the week, he ran it, Snort caught it, he went in and changed one little piece of code which said, when I send this attack and you got to break it into 2 packets, break it here instead of here. If Snort was truly stream-based, if Snort was truly streamed-based, meaning that it reassembles the packets before it performs its analysis, this wouldn't have worked. But Snort says it's stream-based, but it's not. It looks at packets. And Robert Graham showed you can just go right around most IDSs just by changing where fragmentation occurs. This is just ridiculous. Every single one of those hex streams, that's all a period. I can represent a period 8 different ways from Sunday. How is your IDS going to be able to detect the hundreds of thousands of permutations of a SQL injection attack I can do? Assuming you even could find all the hundreds of thousands of permutations of a SQL injection attack. Just think about the bandwidth and the performance your IDS needs to do. It's already got tons of signatures. To add signatures for web apps, you're talking just for SQL injection, 100,000 more signature analysis things it's got to do for every packet that's coming in. This just doesn't scale, and ultimately I end up winning. Dan Kaminsky actually gave a really cool presentation about this, this IDS HTTP fragment attack. Basically, he would take, you know, obviously a web server, when it gets IP fragments, it has to hold them for a certain amount of time until the other part matches, it puts them together and pushes it back up. IDSs and web servers hold a fragment for a long, they don't hold them for the same amounts of time. And so Dan came up with a way of, I could take an attack, break it, and when your IDS reassembles the packets, it looks just like a regular GET request. But when your web server reassembles the packets, it's actually a SQL injection attack. So I just SQL injected you, and your IDS reported that nothing bad happened. Dan Kaminsky is the man. So how does web malware send the attacks? Well, you know, we started talking about this in the hypothetical, but let's kind of get down into it. Well, with a conventional web worm, we're actually executing code on the server. So I can do this any way I want. If I'm in Perl, I can use the Perl LWP library, which makes writing HTTP clients literally a single line of code. Everyone jokes that, you know, Java, you can be like, you know, web server, my web server is a new web server, you know, webserver.start, and you have a web server. In Perl, it's literally like user agent equal, you know, give me a new user agent, get this URL. I mean, it's ridiculously easy to send HTTP requests in Perl. I could use sockets. I could even use netcat, curl. I could even shell out and use wget to send my attacks. So I can basically do anything I want with a web worm to propagate the web worm. For using a pure cross-site scripting-based attack that can hop hosts, or a web virus like the MySpace and the Yammer virus, you're restricted because JavaScript. You're actually executing JavaScript. And JavaScript has kind of some limited ways it can make HTTP requests. First, we've got a unidirectional approach where we can say, I can send something from the target, from the host of the target, but I don't get to see the response. And so, and doing this is basically a blind request. I never see the response. That's not entirely true. This is how Jeremiah and SPY, well, Jeremiah at BlackHat and myself and other people at SPY were able to figure out how to port scan. Because you don't get the full response back, but you do get some error codes. I can basically make arbitrary HTTP gets to any domain on the internet from JavaScript by instantiating an image object or a script object. I can make arbitrary posts to any domain on the internet by dynamically building a form using JavaScript create element and then just simply document.forms.submit and make a post. So it can make requests anywhere it wants blind. It also can do bidirectional. This is where the host and the target can talk back and forth. This is obviously what AJAX is. AJAX allows you to send HTTP, any type of HTTP. You can even send WebDAV using AJAX to the host you came from. And I talked more about this morning, so I'm going to gloss over that. You also, Spy Labs has figured out a couple of covert channels inside JavaScript and about how to arbitrarily send HTTP to any domain on the internet. There is no hard refresh, so it's like AJAX, but it doesn't have the security restrictions of AJAX. Now, it's kind of low bandwidth because we're using some interesting side channels, and hopefully we'll be publishing some more about this soon. All right, web application worms. So really there are two types. I'm going to forget about cross-site scripting for now and just focus on conventional web application worms, which are, these aren't hypothetical. This is real and in the wild. This is, the Perl.Santy is a great example of a worm like this. Basically what happens is these things run on the underlying OS of the web server. They're written in almost any language, you know, Perl, PHP. Like we said, the payload tends to be OS specific. The exploit, it exploits a vulnerability in the target host web application. And I almost always have to allow remote code execution. I can do this through a SQL injection because a lot of times with SQL injection, you actually can call a stored procedure to tell it to execute commands. Or there's just, you know, you've got system or some of these other calls in, say, PHP or C or a CGI gateway that actually allows me to execute code. And there's always buffer overflows too. So I'm simply executing code on the target web app. So first thing it's got to do is find new hosts. So a lot of times it can search. This is a fun thing. Once I'm on the host, I'm in the web root, right? I'm in your iNet pub. So I can start saying, hey, give me all the .asp files, because this code's all running in the server. Let me now use regexes in your ASP or your HTML files and start looking for private IP addresses that are internal IP addresses, or search for other IP addresses, and just basically find references to other websites and go and attack those. Or I could ask a third party. You know, this is kind of where Johnny Logg's Google hacking comes in. Once I own a site through like a PHP BB vuln, the code that's running on the server can now contact Google, look for more sites that are running PHP BB, and then from that site I compromised go. As you know, I really like this analogy H.D. Moore said. It's that concept of, you know, this island has become infected with the plague, and now I'm going to send a little guy over to this island and infect them too. There are some limitations when you're doing this. If I'm attacked, well, actually, in terms of payload and propagation, I can already execute arbitrary commands on the host. I mean, I got command execution. So I can find new hosts. I can do any type of payload that I want. And I can also send these requests, like we talked about using sockets or Perl or whatever, to other hosts. Now, there are a couple limitations. If I pop your a web app and I'm obviously running as, say, in Linux, I'm running under the HTTPD user, the Apache user. In Windows, I'm running, say, maybe as the ASP.NET worker process. I'm not an administrator, so I can only do what the web server did. And a lot of these limitations are given by the underlying OS, the type of security restrictions they apply. At the very least, I can start or I can, you know, change and modify web server settings because I am the web server. We're going to run through that because I don't really care. All right, does anybody have any questions? Yes? I knew people would ask about this. Yes? I don't really want to discuss that right now, but we basically found some side channels in some ways that JavaScript can make requests. And we found a way to basically get other types of information on these side channels. They're not very large capacity. This won't replace AJAX, but it allows you to have bidirectional communications without hard refreshes like a get or a post or something like that. And we're still doing research. I'm sure, I've talked with Ray a little bit about this. I'm sure the VP of engineering right there is going, oh my God, we did what? So, you know, we'll hopefully be discussing this soon. Let me just say that. All right, anybody else have any other questions? All right, cool, moving on. Web application viruses. So this is your myspace.com, your Yammer worm, all those other fun stuff. Again, real live threats. None of this stuff is theoretical. All of this is in the wild. Essentially, what happens with a web application virus is we're reinfecting the back-end database and injecting it with cross-site scripting. So, you know, Ray goes, he visits a page. I've injected cross-site scripting into, you know, he visits my profile. I've injected cross-site scripting into my profile. Ray reads it. The code downloads, you know, the HTML and the JavaScript go down to Ray's machine. AJAX or whatever mechanism I want to use runs, contacts this, you know, host, this social networking host, and reinfects it again. and reinfects it again. This is that concept of, I can never leave the island, but man, I'm going to get everybody's profile eventually, or they'll just shut the server off. Is virus really the correct term to use here? I would say yes. We're really just infecting pages and hosts on the same pages and databases on the same host. Each infection increases the chance that any arbitrary Joe Schmo user is going to come in contact with an infected page. So it's growing exponentially. It can't spread from the host program. It can't leave. It's on that site. And your payloads are generally geared more towards information stealing than destruction. And the reason for this is that we're in JavaScript. We can't access files. We can't delete files. We can't do stuff. I would make the argument that theft is more important than destruction sometimes. Sometimes I could go in and be a real jerk and delete your entire web root. But the fact that I grabbed your entire user database list or all the credit cards out of your web app is probably a little bit more important to you than the fact that I didn't deface your page in the process. So it's interesting. These limitations actually prevent most of the damage we can do to a host, like deleting its files or things like that. So what are the implications of this? This thing is huge. It's truly cross-platform. We saw this with the MySpace. Everybody who was using a Mac or whatever platform, whatever browser they were using, it would run on it. This is truly cross-platform. A lot of these binary attacks, these worms and things from back in the day that said they were cross-platform, all they really were was a single piece of code, and they were able to somehow detect what platform they were now running on. Oh, this is Windows XP versus Windows 2000 versus Windows 98, and then launch the proper payload. The same payload didn't work on everything. Well, we're a web layer. Everything's interpreted. Everything's run in a virtual machine. It'll work on everything. This would work on cell phones that understand JavaScript. Now, the little T-Mobile sidekicks they have a web browser in them. Those actually don't interpret JavaScript. But I mean, that's the type of device I'm talking about. Your Palm, your Trio, anything that's got a web browser that understands JavaScript can further the infection. Now, this is very interesting. These are immune to conventional forms of virus detection because this is stored in a place that viruses normally aren't. The virus is stored in the database with other highly dynamic content. Meanwhile, your McAfee virus tool, it's expecting to work on files. I've got the Yammer worm actually in this box inside a SQL database because I've injected it into a web app. McAfee doesn't fire off a warning saying you've got Yammer in there. But as soon as I copy it to a text file so I can show it to you all, it pops up a warning saying, hey, I found this file and it's got Yammer. So antivirus tools work on files, not text snippets in a database. So once I start injecting your database or I start moving this stuff around, virus scanners aren't going to detect them. Your virus scanner isn't going to hook your web browser or hook your database. It hooks file systems. So the end user and the server user don't really have a way under traditional antivirus technologies right now to even detect this stuff. And like we said, the other interesting thing is if you've got integrity software like Tripwire or you're using MD5 sums, I'm not modifying your file system. I'm not modifying your code paths. I'm not modifying your binaries. So yeah, I haven't violated the integrity of your system. You don't know you've been broken into, and your antivirus stuff can't detect that you've been broken into. So it's also immune to any type of bad JavaScript filter, right? Because, I mean, that's what we're talking about. It always depresses me that our clients and stuff will come to us and say, what can I do to not be a victim of cross-site scripting attack? And unfortunately, the answer right now is not a whole lot, because the attack is that I inject JavaScript into the machine, and your browser doesn't know it shouldn't run this block of code. I mean, why wouldn't it run this block of code? It came from Google. I should execute this JavaScript. The only way you could really prevent